So just to make sure we're all on the same page with this, here is our transverse wave, which basically is looks kind of like a type of standing wave, where here you have your hand, you're taking a rope, you're going up and down with the rope, and you're creating a wave. Okay, movement of the particle is perpendicular to movement of the energy, transverse wave. And here we have a longitudinal wave, where it's like our slinky again, right? Where we're kind of making pulses, sending energy that way, and the wave is also going that way. Remember, we have regions of compression and rarefaction, compression. Okay. Now notice, and we'll be talking about this more, is that waves have a certain velocity. Now, we've talked in this course about the difference between speed and velocity. The difference is that velocity, not only does it have change in distance per time, but it also has direction. So all waves go somewhere, and they have a certain speed with which they travel. Then here, just to kind of point out a few more things about waves, this actually, even the even the longitudinal waves can be described with this sort of kind of scenario down here. But anyway, so here we have what looks like a transverse wave, and here we have crest to crest. That distance is what we call one wavelength. Now, I want you to get used to using the variable lambda. So this is lambda. Meet lambda. And that means wavelength. Okay, length. What else we got? We have amplitude. And I think one of the videos I picked out to show you talks about this. But we have a resting place, which is, I'm running out of colors, I'm picking purple. This purple line right here is the resting or the neutral place, the equilibrium of this green, okay? So that equilibrium place, the disturbance, the maximum disturbance from the equilibrium place is the amplitude. So this figure actually is showing you the amplitude right there. Hope I didn't draw too many lines there. So, all right. Well, one more thing we need to, well, there's more than just one, I'm sure. But another thing with regard to waves is waves are, waves are moving in space with a certain velocity. And as they move in space, there's this important aspect called frequency, the frequency of the wave. And it's kind of cool because basically frequency, if this is our wave, okay, and it's heading this way, if you were to stand here, if I'm a little person, I'm going to go ahead and stand here, and I were to count the number of waves that pass me in 1 second, that's the frequency. So frequency is waves per 1 second. Right. So, for instance, if we are making our, we're talking about a ripple in the water, okay, and you are a person here, hopefully you're above the water, I'm sure we're kind of showing us below the water, but like this says, if you count 20 ripples in 10 seconds, okay, 20 ripples in 10 seconds, okay, seconds, how many ripples do you get per second? Well, that's looking like 2 ripples per 1 second, okay, and actually then that is the frequency. The symbol for frequency is F, and it is, like I said, per second, and I think I might say what it is here. And actually, the per second, instead of saying per second, you've probably heard this term before, we use the unit hertz. So if somebody says it's at 450 hertz, that means it's 450 cycles or wavelengths pass a certain point per 1 second, which is a lot, right? The example I have here is 65 hertz. It means that frequency of 65 hertz means 65 cycles per 1 second.